Okay, in today's video, we're going to work on using and applying the slope formula to what's called average rate of change. So the title of today's notes will be rate of change. And then make sure you put today's date in the top corner of your notes, either up here or up there. So I'm going to give you three circumstances where we're going to do average rate of change. It's going to be using a table, using a graph, and using a situation. So average rate of change relies on slope. So remember, slope is your change in y over your change in x. So that's where you take the y values and subtract them, and then divide it by the x values subtracted. That's slope. So we're going to use this formula to apply it to certain situations, given a graph, table, or a situation. So let's say we had this scenario. Let's say Josh starts a diet. And he decided to record his weight every other week. So we have this person, Josh, who decides to see the impact of his diet. So what we're comparing here is the week and then his weight in pounds. LBS is the abbreviation for pounds. So at the beginning, he initially weighs 224 pounds. After 2 weeks, his weight is 219 pounds. After 4 weeks, he's at 221 pounds. 6 weeks, 215. And 8 weeks, 215 again. So let's say I ask you to find the rate of change at different points of time for Josh's diet. So let's say find the rate of change between week 0 and week 2. So we're going to find the rate of change between week 0 and week 2. So what I'm going to do is I'm just going to list my coordinates. For 0, the weight was 224 pounds. And for week 2, the weight was 219 pounds. And so to find the rate of change, we're just going to use the slope formula. So we're going to label our points x1, y1, x2, y2, and then apply the formula. So I need to do y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So y sub 2 is 219 minus 224 over 2 minus 0. Subtracting these two numbers, I get negative 5 over 2. So using the context of the problem, this means that Josh lost about 2.5 pounds per week at this between those two intervals. So I could ask you to find the rate of change between any points on the table, and you would do the same formula. You would list the coordinates, and then just find the rate of change between those two values. If I asked, for example, to find the rate of change between week 4 and week 8, then you would use week 4 and week 8's numbers and just do the rate of change between those. So for the first 2 weeks, Josh was losing pounds. All right, so another example we're going to look at is when you have to find rate of change from a graph. So the rate of change on a graph, and here you're going to have to tape in the graph that I gave you earlier to start class. Okay, so here's our situation. The graph shows the number of miles driven on a road trip. So this graph is showing the number of miles that somebody traveled on their road trip. So I can straighten out that graph a little bit. Okay, so what if you were asked to find the rate of change between hour 1 and hour 4? So you want to do the same thing as before, where you list the coordinates. So at hour 1, the number of miles driven was 60. So it's going to be 1, 60. And at hour 4, the number of miles driven was 160. So I listed my coordinates, and I'm going to use them and label them my x1, y1, x2, y2, and just plug it into the formula. 160 minus 60 over 4 minus 1. So 160 minus 60 is 100, divided by 4 minus 1 is 3. Hundred divided by 3 is 33.3 miles per every hour. So the rate of change between those 2 points is 33.3 miles per hour. So we've looked at finding rate of change from a graph. We've looked at finding rate of change from a table. The last piece is going to be finding rate of change from a given scenario. Okay, so for the last one, it's going to be a small word problem. So the population of Skokie was 16,200 in 2010, and 13,284 in 2016. Find the rate of change in the population. So we're going to do the same steps. We have to use our data and the information to calculate the rate of change. So we're going to list our coordinates, and we're going to start off with the year and then what the population was. So in 2010, the population was 16,200. And in 2016, the population was 13,284. And now we're just going to apply the slope formula again, just like we did rate of change. So x1, y1, x2, y2. So using the formula, we have y2 minus y1, so 13,284 minus 16,200 over 2016 minus 2010. So I'm doing my y2 minus y1, my x2 minus x1. Subtracting these two numbers, we get negative 2,376 divided by 6. So when you divide that, that turns out to be negative 396 people per year. So the population was decreasing by 396 people every year. That's rate of change. That's applying the slope formula to given circumstances, either in a table, a graph, or a word problem. So you should have enough information now to get started on the practice problems.